This is another relative velocity problem, and in this problem we want to figure out the relative velocity of A with respect to B, and this is equal to the velocity of A minus the velocity of B. So what we need to do is we need to figure out the velocity of A in ijk components and the velocity of B using ijk components. So our velocity of A, if we define up as our positive direction and to the right as our positive direction, we will have a which is 30 times the cosine of 10I minus 30 times the sine of 10J. And we have the velocity of B. And the velocity of B is going to be 45 times the cosine of 25I minus 45 times the sine of 25J. And so since this is velocity of A minus the velocity of B, we put these two equations, we subtract them from each other in the correct order, so we get an equation that is 30 cosine of 10I minus 30 sine of 10J minus 45 times the cosine of 25I minus 45 times the sine of 25J. And what we do now is we combine like components, so we have 30 cos of 10 minus 45, minus 45 cos of 25I, and plus the negative signs will take care of themselves, a minus 30 sine 10 plus 45 sine of 25, and this is the j component, and when we combine them together we are going to get minus 11.23 I component plus 13.81 of a j component. So this is the relative velocity of A with respect to B. Now we can take it a step further. We can figure out the magnitude. So the magnitude is the velocity of A with respect to B. Magnitude is going to be equal to the square root of minus 11.23 squared plus 13.8 squared. And this is equal to 17.8 feet per second. We can also figure out the direction that this is all relative to. So if we look at our components, we have a minus 11.23, and then we have a positive 13.8. This is not drawn to scale, obviously, but we want to figure out this angle right here. If we draw it tail to head, we'll get the right angle, and we can get this angle by saying the inverse tangent of 13.8 over 11.23 is going to be equal to 50.8 degrees. So this has a magnitude of 17.8 feet per second, and 50.8 degrees measured upward this way.